Hello everyone, I welcome all the viewers to this online class conducted by the State Council of Science, Technology and Environment. Today we will deliver a lecture from Chemistry Chapter 5, and the name of the chapter is Carbon and its Compounds. So let us start. Okay, let's start the chapter. The name of the chapter is Carbon and its Compounds. Why do we have to study carbon? It is said that carbon is one of the most important elements for the existence of life on Earth. It is said that though it constitutes only less than 1% of the entire Earth's crust, but yet it forms so many compounds with other elements. Carbon may occur in free states. Free states means that those objects which are made up almost entirely of carbon. They are like, so carbon can occur in free states, just like in diamond, graphite, and coal. But carbon also can combine with other elements to form compounds. Then those are called combined states of carbon. They can either be in the solid state, in the liquid state, or in the gaseous state. So these combined states of carbon, they are the compounds that carbon react with other elements. The liquid states, carbon occur in the form of its compounds in the form of petroleum and vegetable oil. And in the gaseous state, as we know that air contains carbon dioxide, so air itself is a combined state of carbon in the gaseous state. So in the gaseous state we have air, and there's some more, but there's some more the gas that come from petroleum also. They are the combined states of carbon. And in this chapter we will study one important bond between the atoms of different elements, and that is called covalent bond. But before doing covalent bond, we will first recall what is ionic bond. We will call the ionic bond. Let's take the example of sodium atom and chlorine atom. And we know that the atomic number of sodium, is 11, and the atomic number of chlorine is 17. So the electronic configuration of sodium will be the electronic configuration would be, because it's 11, so 2 in the K shell, and then 8, 2 will be 10, and then 1 more. This will be K, L, and the M shell. And in the case of chlorine atom, the electronic configuration would be 2, 8, following that pattern that we have, and then 8, 2 is 10, and then this 17, so 7 more. So in this K shell, L shell, and M shell. So by that duplet and that octet rule, we see that because here this is a third order shell, so for sodium atom to be stable, it must have the electronic of a noble gas element. But in this case, sodium atom, it is an electropositive element. So in this case, it needs to complete the octet structure. So in this case, it can either gain 7 electrons, so that will be 8 electrons in this outermost shell, or it can lose this electron, so that the outermost shell will be this L shell and will have 8 electrons. So for sodium atom, it has that tendency to lose electrons. So if it loses this electron, this outermost electron, it will have 8 electrons in the valence shell. So the octet structure will be completed. So in this case, the sodium atom, it has the tendency to lose this electron. So if it loses that electron, 1 electron, it will become sodium plus. That is, it will become a cation. But whereas for chlorine atom, this is an electronegative element. It does not lose its electron easily. So for it to be stable, it needs to have 8 electrons in the outermost shell. Here the outermost shell is the M shell, and it has 7 electrons. So chlorine atom, for it to be stable, it has to have 8 electrons. So it needs 1 more electron to become 8 here in outermost shell. So what does chlorine do? Chlorine, it wants 1 more electron, so that if it gains 1 more electron, it will become Cl, and because there is excess of 1 more electron, we have 1 negative charge, so it will become an anion. So in this case, when sodium and chlorine atoms, they get close to each other, it will be like this. Sodium, if I write in the Lewis dot structure, which will represent the electrons of the outermost shell. Sodium in the outermost shell, it has 1 electron, so I'll write only 1 dot here. And then chlorine atom, it has 7 electrons in the outermost shell, which is the M shell. So it has 7 electrons. So when they are close to each other, sodium and chlorine, what do? They both of them want to acquire the stable electronic configuration. That is, they want to have 8 electrons in the outermost shell. So what do? This chlorine atom, because it wants 1 more electron, and sodium atom on the other hand wants to lose 1 more electron. So what do? This sodium atom will donate this electron to the chlorine atom. So chlorine atom will gain this 1 electron from the sodium atom. So when they are close to each other, this is what happens. Sodium will lose its electrons, so it will become 1 positive charge. And then chlorine atom will gain this 1 electron. So this 1 electron from sodium will be gained by chlorine atom. So it has excess of 1 more electron, so it will become 1 negative charge. Or in simple way, we can write this just NaCl. So this is how sodium chloride is formed. And this sodium chloride is formed by gaining and losing of electrons. See, sodium is losing its electron, and while chlorine atom is gaining electron from sodium atom. So this type of bond, which is formed by gaining and losing of electrons, this is called the ionic bond. So this is the ionic bond. So this type of bond is called ionic bond. But in this chapter, what we will study more is the covalent bond. So now we will understand what is a covalent bond. What we will remember, in ionic bond, the bond is formed by gaining and losing of electrons. But in covalent bond, we will see now through example. Let us take 2 hydrogen atoms, the simplest atom. So if I take 2 hydrogen atoms, we know that the atomic number of hydrogen is 1. So the electronic configuration will be just 1, because it has only 1 as atomic number. So, which is in the K shell. In the K shell, for it to be stable, it must complete the duplex structure, which means that it has to have 2 electrons. So hydrogen is having only 1 electron, and this one also is having only 1 electron. So what do? If I represent in the Lewis dot structure, this hydrogen atom has only one electron, and this one too has only one electron. So when they are close to each other, what do they do? This hydrogen atom, it wants one more electron for it to be stable. And this hydrogen atom also, it needs one electron to be stable so that it will have the duplex structure to be completed. So what do? They cannot give away this electron. Instead, they want one more for themselves. So what do? When they are close to each other, they will share this electron pair. So if they share this electron pair, this hydrogen atom will have 2 electrons in the outermost shell. And so is this hydrogen atom will have 2 electrons. So in this way, they are stable. So this we can also represent this as, because there is one pair of electrons shared between these 2 hydrogen atoms, so we represent by a single line like this. So see, this type of bond is formed not by gaining and losing of electrons, just like we have seen in the case of sodium chloride, but this type of bond is formed by sharing of electron pairs. So this type of bond, which is formed by sharing of electron pairs, they are called covalent bonds. So let's define covalent bond. And usually elements which undergo covalent bonds, which share the electrons, usually most of them they are non-metals. So a covalent bond, it is a chemical bond formed between non-metals by mutual sharing of one or more electron pairs. It is formed by mutual sharing, means by equal sharing. This hydrogen is sharing 1 electron to this hydrogen atom. This is also sharing 1 electron. So they are sharing equally. So, but in this case, there is 1 electron pair that is being shared between these 2 hydrogen atoms. But we can have more electron pairs also shared between 2 atoms of same element or maybe different elements. But let's take more examples so that we can understand more about the covalent bond. Now let's take the formation of chlorine molecule. Formation of chlorine molecule, which is Cl2. As we know that chlorine has atomic number 17, so chlorine has atomic number of chlorine is 17. So the electronic configuration would be 2, 8, so 8, 2 will be 10, but 17, so 7 more. This is the K shell, the L shell, and the M shell. So in this case, let's represent this chlorine atom with the help of a Lewis dot structure. So chlorine atom has 7 elements in the outermost shell, which is the M shell. So it has 1, 2, 3, 4, 5, 6, 7. And let's take another chlorine atom. It has 7 electrons in the outermost shell. See, for chlorine to be stable, it has to complete the octet structure. That is, it must have 8 electrons in the outermost shell. And this chlorine atom is having 7 electrons in the outermost shell. It needs 1 more electron so that it will become 8. and same thing for this chlorine atom. So what do? When they are close together, you can guess what will they do, just similar to that in the formation of hydrogen molecule. What do? They have 1, 2, 3, 4, 5, 6, 7, 8. They, when they are close to each other, they will share this electron pair. So chlorine will share 1 electron to this chlorine, and this one also will share 1 electron to this chlorine. So if it shares 1 electron, so we'll have 1, 2, 3, 4, 5, 6, 7. If this chlorine shares this electron, so 8 with this one. So it will become like this. So if this electron pair is shared, then this chlorine atom will have 1, 2, 3, 4, 5, 6, 7, 8 electrons in the outermost shell. So this one also will have 8 electrons in the outermost shell. So in this case, they are stable. So because there is only 1 electron pair that is shared between these chlorine atoms, so we can also write this as Cl, and single line. Single line means only 1 electron pair that is shared by these chlorine atoms. Then in that case, chlorine molecule will become stable. But now let's have a look at the case when there is sharing of more than 1 electron pairs. So let's look at the formation of oxygen molecule. Let's look at the formation of oxygen molecule, O2. We know that the atomic number of oxygen is 8. So the electronic configuration would be 2, and then it has 2 but has 8 electrons, so 2 will be 6 more, so it will be 8, K shell and the L shell. So oxygen has 6 electrons in the outermost shell, but because it is a second order, it has to complete the octet rule, which means it has to have 6 electrons in the outermost shell for it to be stable. So it needs 2 more electrons, right? So what do? See if I write the Lewis dot structure again. Oxygen, the outermost shell here is the L shell, and it has 6 electrons. So 1, 2, 3, 4, 5, 6. 6 electrons. And if I have 1 more oxygen, it has 6 electrons in the outermost shell, which is the L shell. So what do? This oxygen has 6 electrons and it needs 8 electrons in the outermost shell. So what do? In this case, they will share these electron pairs. When they are close to each other, they will do the sharing of electrons. So in this case, you will share these 2 electrons. So in this case, there will be mutual sharing of electrons. This is sharing these 2 electrons, and that one also will share 2 electrons. So in this case, there is mutual sharing of electrons, and then when these electron pairs are shared, then see this oxygen will have 1, 2, 3, 4, 5, 6, 7, 8 electrons. So this oxygen will have 8 electrons, so is this oxygen. So in this case, the oxygen molecule is stable. So because here there are 2 electron pairs that is shared between these 2 oxygen atoms, we can also represent this by 2 straight lines like this. So in this case, oxygen molecule is formed. We can also have the case when 3 electron pairs are formed or are shared between the atoms, but for that I will leave to you, but I will write here something. That will be in the case of nitrogen molecule. When nitrogen molecule is formed, then in this case there will be 3 electron pairs that will be shared between 2 nitrogen atoms. We know that the atomic number of nitrogen is 7. So the electronic configuration would be 2, 5. And the Lewis dot structure in the case of nitrogen would be, so this would be in the K shell, this will be in the L shell. So nitrogen will have 1, 2, 3, 4, 5. But when you have two nitrogen atoms, what will they do? 1, 2, 3, 4, 5. You can also do for this one. See, it has 5 electrons in the L shell. It needs 3 more electrons for it to be stable, to have the stable electronic configuration. So in this case, these 3 electrons of these 2 nitrogen atoms will be shared between these 2 nitrogen atoms. So I think you can complete this and you will get, at the end you will get this type of bond that is formed between 2 nitrogen atoms to form a stable nitrogen molecule. Okay, that's it for today. We will continue again in the next class the different kinds of bonds that's formed between, here we see between atoms of same elements, but we will see more about the covalent bonds between atoms of different elements. So I hope you have understood. So until next time, we will see again. Thank you.